I recently watched a video by a YouTuber named Adrian Black who did a teardown on some LED bulbs that he got at Dollar Tree. And I had been talking to a friend about that, and he happened to go to the 99 cents only store, and the 99 cents only store is like that big chain here in the US that they used to have everything for just 99 cents, but lately they've been having other stuff too, like stuff up to like $2, and I don't know if they have anything past $2, but they do have a few things that are much higher than just the 99 cents only that they used to be. So anyways, he found these LED bulbs, and the ones that Adrian Black did a teardown on, they looked fairly decently constructed. I'll link the video down below in case anybody else wants to see that. And they were multi-voltage. They could go from like, I don't know, 120 to like 240 or whatever. And the circuitry inside, actually, they looked pretty decent. So my friend found these. I decided to go check them out myself and go pick some up, and so I could see how these fared compared to those. And already I think that we are not gonna see anything spectacular with these. I actually think that these are gonna be much crappier built than the ones that Adrian showed. For starters, it says right here on the base of the bulb, 120 volt. I don't know if I can get that to focus. Right there, 120 volt. And check this part out right here. Let me see if I can turn this enough to. Oh, okay, we can do it here. But the package says dimmable. But if we look right here, it says not for use with dimmers. So I have a feeling that this is probably not going to have a switching power supply of any sort, and probably very little filtering and regulation and stuff. And it's probably just going to be like a capacitive dropper and maybe some, resistors and stuff. This one here is supposedly a 60 watt equivalent using only 7 watts. And there's two different styles that they had there. And this one here is a 5 watt, 40 watt supposedly equivalent. And we can expect $39 of energy savings if we use this bulb. I can feel the savings already. They saved on the package for sure, because the other ones that I watched the video of, they were actually packaged in like these really nice cardboard boxes. But this blister pack stuff, I hate this stuff. It's like, yeah, it's really tough, and it sucks opening these things. So I'm gonna have to bust out some scissors or something to get these open. So these two here, they're pretty much identical except for the color. This one here is supposed to be a 5000K cool white, and this one's a 3000K warm white. So these are probably going to have the identical construction, except for the the LEDs are just going to be a little different. Although this one here is a 620 lumen, and this one here is a 600 lumen unit. And then this one here is a, what was this one supposed to be? This one's supposed to be a 6400K. So this one's probably going to be a lot cooler looking than the other one. We're going to test these first before we tear them to bits here, just to see what they look like. And then this one here is supposedly only a 350 lumen unit. These are not the only 3 of these that I purchased. I actually got a few more just to test them out, just to see how they did. And the first thing that I noticed using a few more of these is that they have that 60 hertz flicker, which is what leads me to believe that they really don't have much regulation or filtering going on in the power input. And I can really tell that they're flickering. I'm kind of sensitive to that stuff, so I could tell that there's a 60 hertz flicker. When we test it here on the bench, we're going to see how it looks on camera. I'm actually only recording like at 30 frames per second here because I don't like to have like huge video files, but let's see what this looks like first. Okay, so first things first, we're going to use my awesome little purple scissors here to cut this packaging open. I really don't want to tear up my hands trying to tear it open by hand. And that's what the bulb actually looks like. It's like really light, so there's really not going to be much in here to weigh this thing down at all. In operation, the ones that I did try out, they do get fairly warm, like down here on the base. So I'm hoping that there's something there that's dissipating the heat from those LEDs, because they do get pretty warm. So let's bring this thing down here. I'm gonna remove this other lamp from the base. or from the, this is that other lamp I showed before, that I used to light stuff up here on the bench. So now you can see it's kind of dark because I was using it a little bit and I had this CFL in there. So we'll plug this one in to here. Let me zoom out a bit here, you can get a better view. And pardon the mess on the bench here. So there is that, and let's see how this looks when it's turned on. I don't know if we're going to be able to notice much flicker there. And maybe it's slightly noticeable. I can sort of see what might look like some lines here on the camera, but it's not too noticeable. So yeah, it's, I mean, it's, I don't know if me doing this might, maybe you can kind of see it strobing a little bit, although that could be also part of the fact that I'm only recording at 30 frames here. But I can kind of tell, like on my fingers, like as I'm watching it in person, it looks like there's a strobe light on my hands. So that's the cool light, or the cool white one. Now let's bust open this other one here. This one here is supposed to be the warm white, and let's see how this one looks. So yeah, definitely a lot warmer looking, a lot more sort of a yellowish color. And now let's see how this one looks. So this one here should be a lot more bluish looking than this other one here. As you can see, the shape of the bulb itself is also slightly different. This one actually looks a lot cheaper looking than this one. This cap here looks like it's already partially coming off, so this one's going to be like super easy to open, and this one feels even lighter than this one. Okay, so here's that one, and it's definitely a lot dimmer than this one for sure. And you can tell it's a little bit cooler looking, but just barely. Okay, so since this one looks like it's already starting to come apart, let's see if we can pop that. That took no effort at all. This thing just easily popped off, and there's the board with the LEDs, and sure enough, as I expected, there's really not a whole lot in there. So there is no adhesive of any sort or anything. It's just got this sort of like little lip around here. It's not even continuous. It's like it stops here, and then it's a little bit, and then it stops in a little bit, and that just kind of fits into a groove around the perimeter of the base there. And let's see, what have they done here? It looks like they put a little bit of silicone right there along the edge to hold this board in place, and we can see it's not even doing that well of a job because this is just right about to come out. And there's the bottom, and yeah, 2 caps on the bottom there. So bottom there, that's all we got, just like a Mylar cap and then a little electrolytic. The electrolytic here is made by, who's it made by? SanCon. This other one here doesn't say who it's made by, but that's, yeah, that's all it is. So we have our live wire coming into here, and then it goes to, looks like it goes to that big capacitor, the big Mylar one here, and that would jump across to here. That looks like it goes through the rectifiers. So this one at least has some filtering that I can see. So the input, you know, is dropped by the capacitor there, and then it's rectified by this whole bridge here, and then it goes to this cap. So then the cap after that is what goes to all the LEDs there, and looks like, as far as I can tell, they're all connected in series. I might even draw the diagram for this because it looks fairly simple, but yeah, not a whole ton of science going on in there. So yeah, extremely simple little board. It says YL102 down here in the bottom, 23 or 2835, 16 LEDs. So I'm guessing that's the size of these SMD LEDs there, 2835s, and then 16 LEDs. Obviously, there's 16 of them. Okay, so this is what we have for that one. It's just the live coming in here. It goes through a capacitor and a resistor in parallel there. The capacitor is a 1.7 microfarad. The resistor is 470K, and then it just goes through the full bridge rectifier right here, off to the 100 volt 33 microfarad cap right there, and then we have a bleeder resistor of also 470K. So I'm guessing, you know, they're already using this one here. Might as well use it over here too. And then we just have a 16 diodes, the LED diodes here for the output. I just kind of put a dotted line there just to kind of signify that, you know, there's more stuff in between. But that's it. It's extremely simple on that one. So need a little LED board here for a project? Well, there you go. Nice simple little board. Okay, these other ones might be slightly tougher to pop open because they do look a little bit more secure, but I can see a gap here between the base and the lens there. So maybe I can pop that off, or I might need a screwdriver. Let's see, let's get a screwdriver. It's not a screwdriver. Alright, now I got a screwdriver. So let's see if I can jam it right in here without jamming it into my hand. Let me see if I can maybe use this other smaller one to just get it started. Wow. It's coming apart. Slightly. Looks like they did use some adhesive on this one or something. I can feel like something's unsticking there, but it looks like it's silicone as well. Now that I've popped it open a little bit, let's see if I can jam this one in there. And sorry about that. Here we go. There he goes. Okay. So a little bit of silicone all around the perimeter of that. And we got some plastic clips going on here. So those kind of help hold the bulb part on top there. And I'm guessing maybe they did the silicone stuff maybe for just like a little bit of protection against like stuff like water or something penetrating the inside of this. So that's what we have there. We've got this interesting looking little device here. Not sure what that is at the moment. Maybe a fuse? Not sure, but it has an eye on it. Maybe I'll get the macro here. We can look at it a little closer. Okay, here we go. So there's that. It says eye that I have a feeling might be like a fuse. We've got a rectifier over here. And then we have a single chip here that I don't know what that is. Let me see if I can read the numbers on that. That looks like the BP5136, I believe. Yep, that is a BP5136H, and that is a high voltage LED driver, actually. So I'm surprised to actually see that in here. I wasn't expecting there to be a whole ton of stuff in here. I thought this was actually probably going to be similar to that other one. So we have our line, our mains coming into here. We have our live there, neutral there, and then that would get rectified here. So this is, yeah, pretty much going to look like it is going to be a fuse. Gets rectified, and then that goes, we can see the positive here going straight to the LED. These LEDs are all in series all the way around. Looks like we have actually right here, looks like it taps off, so it comes down onto pin 8 of the regulator there, and then the rest of this kind of continues off, and looks like we have another trace here. I'm not sure if that taps off of that. Looks like maybe it does. And then this continues on. We have another tap right there, looks like. Goes off that way into pin 6. And then pin 5 looks like it also goes down to the end here. So kind of curious that this one here, this string of LEDs doesn't really seem to have any taps in between, but then here it looks like they've tapped off every 1, 2, 3. So 1, 2, and then 1, 2. That's kind of interesting. And then we just got a couple of resistors right there. So the negative from the rectifier, so it comes straight into here, or maybe the negative goes to, I'm not sure. I have to look at the pinout for this LED here, or for the LED driver. Alright, so looking at the pinout, no, it looks like the negative here, which would be the ground, would go off into pin 3. So there's no negative connecting to these LEDs. So it's just this whole thing here, which I haven't looked at completely at the data sheet, but I'm guessing what might be happening is they're basically using this as like a voltage dropper. And so that feeds into pin 8 there. According to the pinouts here, it says D1. So it goes D1, D2, D3, and D4. And D4 goes to the very end of the LED strings there. And then the other side's supposed to go through the resistor here over to pin 4, which says VD. So very extremely simple circuit. Yeah, there's basically not going to be anything else underneath, because we already see that, you know, the wires come straight into here. And the base here looks like it is made of aluminum, and there is some aluminum on the inside of the rest of the casing here. So let's see if we can get the rest of this to pop off here. And that's coming up. Just gonna go around here. The silicone's kind of holding it down there too, but I think these wires might also be getting, yeah, you can see that they're getting kind of tight there, so the wires are also not allowing it to come up very much. You can get this to turn enough. We can see down there that there's really nothing. The wire in the center there, that would be the live, just goes straight into that, solder straight into the, actually it doesn't even look like it's soldered. It looks like it's just sort of like smashed in there. You can kind of see right there, so that looks like the wire just gets smashed in between there, and it's just basically almost like a rivet. And then the other one goes off to the side right there. We can't really tell what it's doing, but it's probably just kind of like when they crimp the metal base on here, it's probably just kind of like smashed in there, or that looks like it's, as far as I can tell. So yeah, the whole inside here is definitely being used to sink some of this current, or some of the heat from this plate here. So well, I guess at least they have something. So that explains, yeah, why this base here gets fairly warm. I don't think there's going to be much use in popping this one open here. I'm fairly sure it's just going to be the same thing, just the LEDs are obviously a different color temperature. And I sort of broke that one a little bit. Giving it some twist, there it goes, popped out. And sure enough, yeah, same exact thing. So no point in going into that one anymore. Oh, one thing we did notice here is apparently that's the date. So this was made in on July 18th of 2016, or at least that's when it was designed. What does the other one say? This one says, yeah, same date. So yeah, that's probably when the boards were actually like designed or whatever, spun around. You can see that there's a difference in the filtering there on the LEDs. Jeez, looks like there's a hair. Or is that a... Nope, that's a hair left over from whoever was putting this thing together. So, should extract the DNA and find out who made this. Some stuff here that I just kind of realized that. So this one also says 2835 here, just like the other one did. But this one also says 39.5, so I'm not sure what that's supposed to mean. And then there's a S14P1. Is that what it says? So there's 14 LEDs here. So this 14 probably means like series 14, and then P1 I'm not sure about. So 14 LEDs in series and P1, whatever that means. So I don't know if this would help at all, but since this is the rectified output, I wonder what putting in capacitor on the output here would do. Maybe we should try it. Yeah, we should just get a cap here and solder it directly across and see if it makes any difference. Since I didn't pop this one out of the base yet, I'm going to try it on this one first. Well, I'm just going to try it on this one because this one I already sort of separated, so it's not going to have very good heat sinking there anymore. Oh, one thing I hadn't mentioned yet, that because this one does have the capacitor right there after the rectification, or this diode bridge, this one doesn't have that flicker like these other ones do. Hey, you may notice that the light has kind of changed. I'm using one of the other ones there, that bigger bulb, the one that had the cap just to illuminate for now. So since I'm only expecting the rectified voltage here to be about 170 volts, I'm going to use this 250 volt 22 microfarad cap, solder that across the output of that rectifier there, and then we'll plug it in and see what happens. Hopefully nothing blows up, but in the spirit of experimentation, we'll see. Alright, here we go. A pretty crude job for a pretty crude experiment. Okay, there it is. And the only reason why I'm sort of worried about this thing, you know, potentially blowing up is just because I don't know if maybe they're using, or they're relying on some of that like 60 hertz to, or the lack of, like, you know, complete filtering on that output to have something to do with the driving of the LEDs. I haven't really gone through the data sheet at all, so I don't know. So got some safety glasses on, you know, because it would suck to lose my vision, because then I couldn't do this anymore. That'd be terrible. So let's see what happens when I switch this on. It seems okay so far. I don't see anything heating up or glowing in any way that it shouldn't. And looks like flicker has gone away completely. For the most part. Certainly not as noticeable now, at least not to my eyes. Turn it off here, and I'm gonna feel the base, and it feels warm. I'm gonna unplug it here. I don't want to shock myself, but let's. It doesn't feel overly warm or anything. These LEDs don't feel too hot. One thing I can see, and you can see it on the video too, is that the LEDs right here are still glowing a little bit. Let's leave it on for an extended period of time, and I'll come back and see if anything has failed, or if anything. Well, I mean, I'm not going to just abandon the thing. I don't want anything to burn down either. But I'll just let it run for a little bit, and I'll see if anything happens or not. I wish this thing would stay. Okay, we'll just leave it there. Okay, so I let this go for about 5 minutes here, and nothing has burned up, nothing blew up, and it seems to be operating pretty stable. One thing I do also notice is that it seems to be a little bit brighter with the filtering going on there. So just so we can see what the difference is between having some filtering on the output there and not having anything at all, I'm going to turn this off. I'm going to unplug it, and I'm going to clip one of the leads on the capacitor there. I'm trying not to short anything here, and I'm just going to make it so that I can like make contact with it without shorting anything, so that way I can just kind of push on it there. You can see that the LEDs light up, and we can see the difference in light output. Okay, so no filtering. Well, yeah, no filtering there on the output of the rectifier. I'm going to turn it on, so we have that sort of light, and then once I touch the cap, you can see it got slightly brighter. So no capacitor, capacitor, no capacitor, capacitor. So it does affect it a little bit. Ooh, flash. I'm guessing maybe the reason why this doesn't have any filtering by default is probably just as a cost-saving thing. I mean, how are they going to sell this thing for $1 if, you know, it's got too many components inside? Although those other ones that they had at the Dollar Tree that were a lot nicer with their power supply section. They had a whole little transformer and everything. They were just really fancy compared to this thing. Alright, well there we go. So I hope that was kind of interesting. I would not say, go and get one of these and put a capacitor in it, because obviously they were not designed this way. And I really don't know the long-term effects of having a capacitor on there, whether, it overdrives the LEDs or anything. So this was just an experiment. As we saw here, the simplest of the three was this one with nothing but just rectification and some filtering right there. But at the same time, that also means that the light output is a little more consistent. It doesn't have like that flicker that these other two do. Although this one here doesn't seem to have any sort of protection at all as far as like a fuse or anything. It's just power straight in through the cap, and off it goes. These here apparently do have at least some sort of fuse there. So just a tiny little bit of protection, I guess. Alright everyone, well thanks for watching. Remember, if you like this kind of stuff, to thumbs up, and if it's your first time watching this stuff and you like this sort of content, be sure to subscribe. Thank you guys again for watching. I'll see you guys around the bench.